So this is running Kubernetes in the browser. Yes, really, not really, kind of. Or why we keep reinventing things but nothing gets any simpler. So I'm Nate Abele. Thank you for the opportunity to speak to you all. It's great to be back in Greenville. This is a picture of me in case you don't know what I look like. I'm on most of the internet as @NateAbele, and if you either love or hate this talk, I would love to hear from you. There's my email address. You'll have to excuse my voice because I'm getting over a cold, and you'll have to excuse my demeanor because I hate computers. You may know me from these popular open source projects. If you've shipped any apps on them, you're welcome, and I'm sorry. So how did I end up here? Basically, Barry goaded me into submitting a talk, and then he accepted it. Based on a crazy idea of replacing Kubernetes with Elixir and WebAssembly. And if that makes no sense to you whatsoever, congratulations, your grip on reality is firm. Barry, I apologize. I have to break the no politics rule momentarily to talk about mangoes. Mangoes are the best and most delicious fruit, and if you disagree, you are wrong, and I will fight you. This concludes the political portion of the talk. So, other than for the fun of it, what is the point of replacing Kubernetes with Elixir and WebAssembly, and what would that even mean? Well, let's start at the beginning. In the beginning, there were no computers, and frankly, this was probably for the best. Some years later, the Greeks wanted to predict the positions of astronomical objects, and this was still fine because there was no software involved. Fast forward to the mid-1800s when Charles Babbage designed and built his difference engine. Still no software, so far so good. In 1963, Ivan Sutherland developed Sketchpad, which featured, among other things, programming by direct manipulation. Notably, it was one of the last times in history when someone shipped a simple piece of software that actually worked and did basically what you expect. In 1983, just a scant 20 years later, the TCP/IP protocol was invented, which led with some help with US politician, from US politician Al Gore, to the birth of the internet. January 1993 saw the birth of NCSA Mosaic, which ushered in the World Wide Web. Later that year, an approach known as the Common Gateway Interface was formalized, which for the first time ever provided a standard way to run software on the internet. This popularized many write-only languages, such as Perl, but was mostly the domain of C, C++, and in particular, Bash. This is important. We'll come back to it later. Shortly thereafter, the industry graduated to uploading PHP scripts over FTP. Very important. This critical milestone made it possible to do rapid, friction-free deployments when editors began enabling directly integrating support for editing files over FTP, which is great. Over time, the industry began to standardize on self-contained software stacks, such as the LAMP stack, and adopted tools like Hudson, which were widely loved for its interface and ease of configuration. And tools like this began to be used for automating deployments, testing, and other operational tasks. In 2006, exactly 18 years ago tomorrow, Amazon Web Services launched EC2, which in the years following, it would go on to launch a number of ancillary services, which led to the practice known as immutable infrastructure, wherein machine images would be baked by automated tooling and stamped out on virtual machines, which were enabled rolling deploys, blue-green deploys, rollbacks were straightforward, builds were fast. This period was considered by many experts as peak infrastructure. 2013 saw the release of Docker, which was excitedly adopted by much of the industry, conceding the fact that it was so bad at isolation that achieving any sort of guarantees requires putting a computer inside a computer inside a computer. Which a practice which is still widely regarded as industry standard. In hopes of using this new technology to simplify application architecture, software teams began inserting as many network boundaries as possible between critical application subsystems. So now faced with the perhaps unanticipated challenge of coordinating these many subsystems, the industry made the obvious choice to reinvent the operating system. naturally, the competitor to win industry favor was the most comprehensive. So whereas historically technological revolutions would obviate labor-intensive jobs, inefficient processes, and redundant cottage industries, the software industry chose to chart a bold new course in exactly the opposite direction. And it just keeps going. It's really quite impressive. And naturally, the way in which all these systems are configured is YAML that generates YAML interspersed with string fragments that generate YAML. And to bring it full circle to the birth of the web, a significant quantity of bash scripts. Now, but now we know why. According to this documentation obtained under the Freedom of Information Act, it reveals that the Cloud Native Computing Foundation is actually a conspiracy by major tech companies to suppress competition by keeping the industry chasing its collective tail with patently absurd, overhyped technologies. All right, so this is the part of the talk where I drop the sarcastic act and we have some real talk. The problem is us. Absent a huge amount of intentionality and focus, things will continuously, incrementally, always drive towards ever-increasing degrees of complexity. In other words, our usual approach is not going to work here. The thing is, we've learned these lessons before. There's a reason things like functional programming are so popular now. There's a reason that the Unix model is still such a popular model for operating systems. Don't groan. Once upon a time, you had to learn what polymorphism meant too. Homoiconicity is the idea of things having the same form or the same shape. The Unix model is great because everything is just text streams in and out. And you can use pipes to compose simple tools together to create complex behavior. Functional programming is the same thing. It's great because you can compose simple functions together with function composition to create complex behavior. And everything is just functions and data. So the alternative is that everything is a special case. You end up with APIs like Java's or Kubernetes, or for those of us old enough to remember, gulp-star and grunt-star packages in the JavaScript ecosystem. Essentially, when you have a combinatorial explosion of individual single-purpose named things, that is a tell that the ecosystem has failed to provide the right primitive abstractions for the problem domain. So you've all heard of WebAssembly, and many of you have probably heard of the WebAssembly System Interface, or WASI. A number of years ago, the inventor of Docker tweeted that he wouldn't have needed to invent Docker if WASM and WASI had existed at the time. This is a really powerful pair of primitives for this problem space. And these technologies can do basically everything that a container can do, and it adds a whole bunch of other benefits. So let's talk about WASI first briefly. So it's basically like mini POSIX for WebAssembly. It's an interface spec, so you kind of bring your own OS, mini OS, in terms of POSIX interface. And it allows you to have capability-based security. And WASM is already fully sandboxed, but you can allow or deny network access, file system access, and it's fine-grained. So if you want to say this particular module can only access this set of domains, you can do that. It can only access this set of file system paths, etc. So you can restrict on basically anything that you want because it's completely plug and play. So WASM. Not only is there probably an embeddable WASM runtime for your favorite programming environment, but your favorite language probably also compiles to it. And if it doesn't, just containerize it, and then cross-compile the container to WASM. So let's talk about Elixir. Elixir is great in and of itself, but really the great thing about Elixir is the beam, the virtual machine that powers it, and Erlang and several other languages. Which means I can use another Beam language like Gleam, which also cross-compiles to JavaScript. So I can stick it in a browser. Anyway, the Beam is really the ideal platform for building distributed systems because it's exactly what it was designed for. So it provides the right primitives for some really great examples and understanding of why. I highly recommend this talk, The Soul of Erlang and Elixir. For our purposes, the killer features are really the built-in clustering capabilities and the ultimate superpower, shipping closures over the wire. So if I can ship a closure over the wire, I can ship a complete live system process over the wire because it's all just WASM modules running in process, which obviates the need for many of Kubernetes capabilities and greatly simplifies system lifecycle processes. So target features, running in the browser. Why? Running in the browser is really kind of a litmus test, because if I can run it in the browser, I can run it anywhere. And it means the runtime is fully encapsulated. And if the runtime is fully encapsulated, you can actually simulate behavior in isolation. So imagine being able to simulate a complicated deploy or a rollback, or simulate how your distributed system is going to behave under a certain set of conditions. And if I want to simulate clustering, I can just open a few tabs. To be able to have a backend proxy plus WebSockets so that the browser can actually talk to the backend proxy and serve requests, serve HTTP requests directly out of the browser to an outside system. And be able to push WASM modules into the runtime, into the orchestration platform. And route internal and external requests. So route requests from outside to a module and route requests between modules. And external services via WASI. This basically completely replaces the Kubernetes concept of operators. And finally, middleware. So this is where the idea of homoiconicity really comes in. Most capabilities we really want out of container orchestration are basically just fancy middleware. And we have middleware in every popular backend platform. It's basically just functions. So that means the way that we build the control layer is now basically the same as the way we build the application layer. And it's no longer special by comparison. So I was going to do a demo, but frankly it doesn't demo that well without a fancy dashboard, and I just didn't have time, and I kind of like sleeping sometimes, occasionally. So that's all I've got. This has been running Kubernetes in the browser. The slides will be linked on my website later today. If you'd like to work together on this, please get in touch. Once again, I'm Nate Abele. This has been running Kubernetes in the browser. I am here to help you and your team take it to the next level. And with Robot Summer Camp, I help your kids learn to love technology and creating with it more than consuming it. Thank you.